Hello guys, welcome back to STEM Trainers. So in the previous video, we saw how to find stationary points. Now today we will see how to find the local maximum and local minimum points. Okay, so as we discussed in previous class, stationary points where dy by dx is 0. Now, whenever you have a stationary point can be a local maxima. As you can see, a stationary point can be a local maxima, that is one. A stationary point can be a local minima, and a stationary point can be point of inflection or inflection point. So in this video we will see the first two, that is local maxima, local minima. In the next video we will see the inflection points. Okay, so question is, we know how to find stationary points, so how can we differentiate between local maxima and local minima? So there are mainly two ways. There are actually many ways, but as in your curriculum you have two ways. First is first derivative test, and second method is second derivative test. So you must understand these two methods perfectly, otherwise you might lose some marks. Okay, first one, let's understand what is first derivative method. Now consider this graph. As you can see, point A I am taking as a stationary point. Let's call this as point A. This point B is B comma f of B, and it is also a stationary point. Now as you can see, this point A is the highest point or highest value of y in the neighborhood. What do you mean by neighborhood? Neighborhood, I mean, is in just the interval, small interval which contains A. So in this small interval, let's take this small interval. In this interval, A has the highest value. So this point is known as local maxima. That's why it is called local. Local means in a small neighborhood or in a small interval. Local maxima. Or sometimes we just skip this local and we just call it maximum point or maxima. But the better definition you can say is local maxima. Okay, and similarly, as you can see, if I take a small interval around B, then B point has the lowest value of y, or the curve has the lowest value, and that's why this is known as local minima, or you can just call it minima, no problem. Okay, so now we understand what is local maxima, what is local minima. Now question is, how to differentiate this? Now, first thing first, this is 100% we are sure that at point B, f dash x is 0. So if you draw a tangent, its gradient is 0. Now consider a point that is to the left of A. So at immediate left you have to take, but you can just take here also, anywhere, just take left of A. If you draw a tangent, this is the tangent. This is tangent to a point which is to the left of A. You can see that gradient of tangent is positive. Now there might be some students who are asking or who are thinking, why gradient is positive? So simple, because you can see this is the tangent, then this angle is acute that this tangent is making with x-axis, and we know tan of gradient is nothing but tan of theta. Theta is the angle made by the line with the x-axis. So this angle is acute, so hence I can say gradient is positive. Now if you take any point that is to the right side of A, so the tangent will be something like this, and you can see that this angle made by this tangent with x-axis, positive x-axis in anti-clockwise direction, will be obtuse. So I can say my f dash x will be negative, or I can say simply say f dash x is negative. So what happens is, If point A is a point of local maxima, then to the left of A you have gradient positive and to the right of A you have gradient negative. So that is what is written here in the first derivative test. As you can see, local maxima. So at the point A, my f dash x is 0, and to the left of A, x minus h, where h is a small quantity or a small number, small positive quantity. So basically we are going to the left of that point A. So my gradient should be positive, and to the right of my local maxima, my gradient should be negative. Now similarly, we can do this analysis for point B, that is local minima also, and you will find that at local minima my f dash x is 0, and to the left of local minima my gradient is negative, and then to the right of point B my gradient is positive. So this is known as the first derivative test. So we will see when we will solve questions how to use this. So this is just for understanding. So generally I remember it like this. If you go from positive to negative, as you can see, this is gradient. So if you go from positive to negative, you have local maxima. And if you go from negative to positive, you have local minima. So I remember it like this. Instead of remembering to the left of this is positive, the right is negative, I remember it like this. Positive to negative, if you go, you have local maxima. Negative to positive, if you go, you have local minima. Okay, this is the first derivative test. That is one way to differentiate local maxima, local minima. Now this is the second way, which is more popular among the students because this is easy to understand. So let's say you have x equal to a stationary point. Then what you do is you find double differentiation of f and substitute the coordinate a. Then if f double dash a is positive, then it means x equal to a is a point of local minima. And if you have f double dash a, that is double differentiation of f at the point x equal to a, gives us a negative value, then we say that is a point of local maxima. Now there might be cases where f double dash a is 0. Actually I haven't written it, but there might be a case where f double dash a is 0. Then we say this second derivative test is inconclusive. So using second derivative test, we can't differentiate whether it's local maxima, local minima, or what. In that case, what you have to do is we have to go for the first derivative test. Okay, we will see one example and try to understand how to use these two tests. Okay, first one. So a curve has equation y equal to 2x cube minus 5x square minus 4x plus 2. So curve is given. We have to find the coordinates of stationary point. Okay, so we have done this in previous video also. Let's quickly solve this now. So y dash means dy by dx or f dash x is equal to, this will be 6x square minus 10x minus 4. And for stationary points, this should be equal to 0. So let's simplify this. So you can take 2 out. This will be 3x square minus 5x minus 2. Now let's make factors of this. So this will be equal to 3x and x. This should be minus x, right? So this should be minus 2. This should be plus 1. So 3x plus 1 and x minus 2 are the factors, and this is equal to 0. So this is nothing but my f dash x or dy by dx, same thing. Okay. Now let's find the stationary points. So f dash x equal to 0 gives us x as minus 1 over 3 and x equal to 2. And remember, once you have x value, so now we have to find the y value also for stationary points. So when x is 2, let's find y value. Using calculator you can find, or you can orally solve it, whichever you like. 2 into 2 cube minus 5 into 2 square minus 4 into 2 plus 2. So this will be 16 minus 20 minus 8 plus 2. So this is nothing but 10. So y is coming out to be 10. Second stationary point, when x is minus 1 over 3. Let's substitute. We will get, okay, 2 times minus 1 over 3 whole cube minus 5 times minus 1 over 3 whole square minus 4 times minus 1 over 3 plus 2. So let's simplify this using a calculator. So this will give us 2.7. Okay, so this is my x coordinate, this is my y coordinate, and this is my x and y. So I got 2 stationary points. So now I have to see which point is local maxima and which point is local minima. So now what we will do is, we will solve this using both the methods, that is first derivative test and second derivative test. We will see using first derivative test, how to use that. So first derivative test. So what you will do in this is, you have your f dash x expression, that is 2 times 3x plus 1 into x minus 2. So what I will do is, I will mark a line and mark the critical point, that is minus 1 over 3 and 2. So now I have to see the signs of f dash x. So f dash x is obviously 0 at minus 1 over 3, and obviously it is 0 at x equal to 2. So what happens if x is greater than 2? Then you can see here, if x is greater than 2, you have a positive value of f dash x. So I can just write here positive, and it will be negative when it is between minus 1 by 3 and 2. And when it is less than, when x is less than minus 1 over 3, then f dash x is negative. Now there might be some students who are wondering why or how I am writing this negative positive thing. So how I am doing is, I am just finding a point. For example, between minus 1 by 3 and 2, just pick any point. For example, 0. Substitute in this and see whether f dash x is positive or negative. So similarly, when it is less than minus 1 by 3, or you can just think about this, when x is less than minus 1 over 3, this will be negative, and this second expression will also be negative, hence it is positive. So you are getting f dash x signs as positive, then 0, then negative. Now remember, whenever you go from positive to negative, so what happens is, you get a local maxima. I think I told you, remember it like this: whenever the sign changes from positive to negative, then you have local maxima. And this is going from negative to positive, f dash x around 2. You can see less than 2 it's negative, then 0, then positive. So negative to positive you are going f dash x. This is nothing but f dash x. Then you have a local minima. So this is my first derivative test. So in first derivative test, you have to see signs of f dash x, and then you can decide it is local maxima or minima. Now let's see the second derivative test, which is students' favorite because it's easy. Okay, second derivative test. So what we will do is, we will differentiate the curve 2 times. So obviously we have f dash x, that is 6x square minus 10x minus 4. So my f dash x was 6x square minus 10x minus 4, and my stationary points were 2 and minus 1 over 3. So what we will do in this is we will differentiate this again. So we will get f dash x, f double dash x is equal to 12x minus 10. And now we will find f double dash x values at the stationary point. So at 2, I am getting f double dash 2 is equal to 24 minus 10, that is 14, which is positive. So whenever f double dash x is positive, it gives us local minimum. So local minimum. And similarly, we will find f double dash of minus 1 over 3. So minus 1 over 3, it will be minus 4 minus 10. That is again minus 14. Okay, so minus 14 means less than 0. Less than 0 means local maxima. So this point is local maximum. So that's our answer. So see, you're getting the same answer. Minus 1 by 3 local maximum, minus 1 by 3 local maximum. So finally, when you will write the answers, just be careful to write the whole answer. So by whole answer, I mean is you have to write 2, 10 is my local minimum. These are the coordinates of the local minimum for fx. And minus 1 over 3, 2.7 or 2.6. You can use calculator to find this value. So this will be local maximum. So this will be our final answer. So this is how to use the first derivative test and second derivative test. If you have any doubt or any query, you can just write it in the comments or you can email me. Okay, thanks for watching STEM Trainers.